Morning, Trick fans. How we doing on this fine Tuesday morning? Yes, it is Tuesday morning. It's a little chilly outside out there, but it's okay. It's a Tuesday morning. We're getting near the end of things that we have to accomplish in this class, which is good. Continue to push yourself forward. Continue to push through it. You can do this. You've done a nice job up to now. Continue to work through the material, and we'll get through the material that we have to get through. We have one more day of law, sines, and cosines. Once again, tomorrow we will have a review sheet. Thursday we'll do the evaluation, and Friday we will once again utilize for you to, if you need to make up any work at that point, you can get any work done that you can. I sort of give that day to you to be able to try to catch up if you need to catch up. So today we're going to go through one more day of law, sines, and cosines. And we're going to go through what is called the ambiguous case. The ambiguous case with respect to triangles. If we have a triangle ABC here, triangle ABC, we have little c is equal to 8, little b is equal to 7, and we want to calculate little a down here. We want to calculate little a. Well, if we look at what we have here, we have a nice little setup for a law of sines, but we're not going to be able to find little a directly, which is fine. Okay, but if I know angle B and I know little b, and I know little c, I can find angle C by using the law of sines. So if I have the sine of angle B over little b, this is going to equal the sine of angle C over little c. This is what we talked about yesterday with respect to law of sines. The ratio of the sine of an angle to the length of the side opposite will be in proportion for any triangle. So if I substitute my values in here, I have the sine of 50 over 7 is equal to the sine of angle C over the value of 8. Now we can cross multiply here, cross multiply and divide. So we're left with the sine of angle C is equal to 8 times the sine of 50 over the value of 7. So I can clickety-clack that through my calculator, if I can find it. So we have, let's see, 8 sine of 50, close my parentheses, divided by 7, I get 0.875. And some extra change there. But that's the sine of angle C. How do I calculate angle C? Well, what do we have to do to both sides to get rid of sine? That's exactly correct. We take the inverse sine. So we take the inverse sine of our answer, and we get 61.1 degrees. So angle C is 61.1 degrees. And once again, if I'm going too fast, I will not take offense if you hit your pause button. Okay, just slow me down. So if I know this is 50, I know this is 61.1, now we can go back to our old school days of geometry and Dr. Clark down there. How do I find the measure of angle A? That's correct, all these angles have to add up to 180. So I can add these two together and subtract from 180. So we have 61.1 plus 50 minus 180, and we get 68.9 degrees. So that's 68.9 degrees. Now once again, I could go back to my law of sines to be able to calculate. And once again, I would go back to the ones I know for sure. I have the sine of angle B over little b equal to sine of angle A over little a. So substituting in, we have sine of angle B, which is 50, over 7 equals sine of 68.9 over little a. Once again, cross multiplying and dividing, a would equal 7 times the sine of 68.9 divided by the sine of 50. Just cross multiplying, diagonal multiply, divide by the third value. So one more calculation here. I have 7 sine of 68.9 divided by sine of 50. We get 8.53, or 8.5. For little a. And we have done everything here correctly. We have just gone back and sort of utilized a bunch of different ideas that we've talked about the last couple days. But what I want to pose to you is another option. Here we have the exact same triangle ABC. What I'm going to do, try to attempt, is I'm going to swing this arm. Here is a length of 7 for this, and I'm going to swing this arm over and have the length of 7 there still. All I've done is I've created a nice isosceles triangle. Okay, this is length 7, this is length 7. Okay, so this is 7, this is still 8, I didn't mess with that, and this is still 50 degrees, I didn't mess with that. So what we have here is we have another option for this triangle. Well, up here, I did all my calculations correctly. Everything is correct. This is my answer, boom, that's it. Drop the mic, boom, I'm out of here. No, that's not drop the mic, I'm out of here, because we have another option. Well, the question is, how do we find this other option? How do we find these other solutions? Because everything up here is correct. What other magic do we have that would allow us to be able to find these other values? Man, where's that magic come from? Do I need to pull out my magic wand here and create something? What do I do? Well, think back to a process. When we are solving trig equations, and we're going to take a look at this step right here. We had the sine of angle C is 0.875, and to solve this, we had to take the inverse sine. Well, when we take the inverse sine, we came down to two solutions. We had the calculator value, which we called the principal value. We had that value. Easy to find, the principal value. But when we did the inverse sine, what other value did we have to come up with? Think. That's exactly correct. We had to worry about its supplement. So we came down to the measure of angle C was 61 degrees, 0.1 degrees. But we also have to worry about its supplement. Well, how do we find the supplement? Well, supplements are angles of two angles that we add together to add up to equal 180. So we can subtract 180 minus 61.1 degrees. Clickety-clack, clickety-clack. 180 minus 61.1 degrees. And what we come down to is 118.9 degrees. 118.9 degrees. Now if we take a look at this triangle, what we formed here, and it's close to drawing the scale, is this angle C is a now obtuse angle. So we have 118.9 degrees here. This is 50 degrees. What's angle A have to equal? Well, I could take 118.9 plus 50 plus 50. I get 168.9 minus 180. I get 11.1 degrees. So this angle here is 11.1 degrees. Which now allows me to find little a by using my law of sines. So we have the sine of angle A over little a equals the sine of angle B over little b. Substituting in, we have the sine of 11.1 degrees over little a equals the sine of 50 over little b, which is 7. Cross multiplying and dividing, a would equal 7 times the sine of 11.1 divided by sine of 50 degrees. So once again, we can clickety-clack through the calculator. 7 sine of 11.1 divided by, oopsie, goes my parenthesis, divided by sine of 50, goes my parenthesis, I get 1.76. Now what we should always check in all of our problems, the biggest side is across from the biggest angle, the smallest side is always across from the smallest angle. That's one of those properties of a triangle. Here I have 118.19, biggest side, biggest angle, they're opposite, 57, middle, smallest, smallest, that works. If I take a look up here, 68.9 is my biggest angle, 8.5 is my biggest side, 50 is my smallest angle, 7 is my smallest side. Both triangles work. Both triangles are options. Now, as you go through the process of the law of sines and using the law of sines, when dealing with using the law of sines to find the angle of a triangle, what you have to be wary of when you're trying to find an angle, we have two solutions, two possible solutions, the principal value and its supplement. Now, I'll ask you this question. How many obtuse angles can a triangle have? Only one. So if there's a triangle there that's already, there's an angle there that's already obtuse, you're not going to get a second obtuse angle, so I don't have to worry about a supplement, because supplementary angles are always going to be obtuse angles. So I don't have to worry about that. Now, if we think back to your fond memories of geometry, over there with Dr. Clark, you down there sitting there with Dr. Clark, and you're proving triangles congruent. The first one that you went through was a side postulate. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles were congruent. Then you proved a side angle side postulate that said if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, the two triangles will be congruent by side angle side. And then you learned an angle side angle postulate. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, the two triangles are congruent. And then you learned an angle side or angle side. Two angles on a non-included side of one triangle congruent to the two angles on the non-included triangle side of a second triangle. The two triangles were congruent. And these were how you proved triangles congruent. But of course, as you sat back there in geometry class, there was somebody who was pondering and probably asked the question of Dr. Clark. Well, Dr. Clark, you have all these ways of proving triangles congruent. Why don't we have the angle side postulate, Dr. Clark? Why don't we have that? If we have two sides and a non-included angle of one triangle congruent to two sides and a non-included angle of a second triangle, why don't we have this? Why don't we have this? The angle side, Dr. Clark, why don't we have it? And no, I'm not going to write it the other way around. Sorry. Well, right here is the reason why. What we have in these two triangles that we just drew, we have two sides, the 7 and 8 are congruent to these 7 and 8s, and a non-included angle. This angle B is 50, this angle B is 50. So we have two sides and a non-included angle of one triangle congruent to two sides and a non-included angle of a second triangle. But obviously, these two triangles are congruent, because if they were congruent, I would be able to put one right on top of the other, and you would just make one triangle. And we don't have that. We don't have congruent triangles here. Hopefully you can realize that. Now, you could put a corollary to this. If this angle was obtuse, then this would be true. This would be true. If this angle was obtuse, then these two triangles would be congruent. But that's not a corollary. It should be. It could be the Gregory corollary of proving triangles congruent. But the triangle would have to be, this angle would have to be obtuse for this to be able to work, and it's not. So that is the reason why you don't have the side-side angle postulate in proving triangles congruent. Okay, this is the last of the new material. I gave one more problem, which is a multiple problem on Google Classroom for you to work through today. It goes through this idea a little bit more. But other than that, tomorrow, once again, will be a review day. I'll have some other ideas in regard, or I'll have some law of sines problems there, some side-side angle postulate problems there. You just have to watch when you calculate an angle with the law of sines. You have to watch to make sure that you don't have a second solution, because there's possibility of a second solution. If you want to guarantee having the correct angle every time within a triangle, you use your law of cosines. Law of cosines will guarantee the correct angle. Because when I do the inverse cosine, I get two solutions, the principal value and its opposite, but putting a negative 30-degree angle in this triangle would not make too much sense. So the law of cosines will always give you the correct angle. It's a couple extra steps. I know the law of sines is a lot easier to work with, but it will always give you the correct angle. So once again, tomorrow will be a review day. Thursday will be the evaluation for this week over law of sines, law of cosines, and some area problems, and that will be it. If you have any questions, feel free to comment me, ask me questions. I know yesterday I botched up, I didn't put a correct angle in there. That was my fault. Other than that, if you have any other questions, please feel free to ask, comment me, I'll try to get back to you as quickly as possible or fix any problems I may have developed in those little evaluation things. Please do the evaluations. It's like a homework problem, which is just extra practice for you to be able to go through things. Tomorrow will be a review day. Thursday will be evaluation. Friday will be a makeup day. So weeks go fast here. Weeks go fast. We'll get through this as quickly as possible. Hope everything is well with you and your family at home. Hope everything's going okay. Social distancing, they're starting to open things up a little bit more. Things are going to start getting back to a little bit, hopefully back to some sort of normalcy. Okay, we can only hope. Other than that, I have nothing else for you. Adios. You folks have a great day. Miss you guys.